Welcome back to physics class. Children, step by step, when we are trying to solve the problems, somewhere we are finding easy, isn't it, for solving the next problem. In the same way, in today's class also, we will solve few more problems based upon Ohm's law, isn't it, children? What it says? That is, V is directly proportional to I, which is nothing but a V is equals to I into R. Based upon this formula, today we will solve the numericals. So, let us look into the first question. A potential difference of 20 volt is applied across the end of a resistance having a 5 ohms. Means here 20 voltage source is applied across how much ohms resistance, children? 5 ohms. Then what current will flow in the resistance? They ask directly find the value of a current. So first what we have to do? The data we have to collect. That is what? Potential difference. In short we can write V is equals to 20 volts, isn't it, children? Then resistance R is equals to 5 ohms. Current we need to calculate, so keep it question mark. Now using formula V is equals to I into R. This is what? Formula. We want which variable? I we want. So we can write this as a I is equals to V by R. Isn't it, children? Now we will substitute the given values. That is I is equals to, what is V value? 20 volts divided by R is 5 ohms. 5 ones are 5 fours are. That is volts per ohm is nothing but a ampere. Isn't it, children? So which is equals to 4 amperes. That is I is equals to 4 amperes. Children, after completing your problems, you should not forget writing its unit. Suppose everything you have solved, if you forget to write its unit, means definitely you are going to lose half mark, isn't it, children? So keep it in mind. Whenever you are solving the problems, means at last you have to write their units also, and it is very important to write a units. Got it, children? How to solve? Okay, now we will solve the next problem, and the question is, a resistance of 20 ohms has a current 2 ampere flowing in it. Then what is the potential difference between its end? See here, in the initial problem, we were calculated what? Current I value. Here, the current value has given and resistance value has given. They asked us to calculate a voltage, that is potential difference value. So, using the same formula, R is equals to 20 ohms, I is equals to 2 amperes, then V is equals to how much? So what we should write first? Formula V is equals to I into R. Isn't it, children? There is no need to change the formula now, isn't it? So now substitute the given values, that is V is equals to, what is I value, children? 2 amperes into R is what? 20 ohms, which is nothing but a 20 to the 40 volt is the potential difference across its end. Got it, children? 40 volts is the voltage across this circuit. I think this you all understand and finding easy to solve the next problem, isn't it, children? First what we have to do? We have to read the questions and we have to analyze what the given data, isn't it, children? Afterwards, based upon that is a formula we have to use, and afterwards we need to substitute the given values, then we'll get a answer. Got it, children? Okay, now we'll see the next one. Children, the next question is, the current of 5 ampere flows through a wire whose ends are at a potential difference of 3 volts. Calculate the resistance of the wire. Here, what are the given things, children? The current I value has given, then potential difference value is given. So, directly we need to calculate what? Resistance value. Isn't it, children? So, what we have to do? Given I is equals to 5 amperes, then V is equals to 3 volts, R is how much? So, using formula, V is equals to I into R implies what? R is nothing but a V by I. Isn't it, children? So, now substitute in that. Then what becomes? R is same as it is. Then what is the V value? 3 volts. I is 5 amperes. Isn't it, children? Now multiply this. That is divide this. Sorry. 5 and it is not going. So 0.6 ohm is the answer. Isn't it, children? So the resistance of the wire is 0.6 ohm. Isn't it? Because 3 is smaller, so we need to take a point, then 6 are 5 6 are 30. Okay, what is the resistance? 0.6. Now we will look into the next one. That is, the question is, the potential difference between the terminals of an electric iron is 240 volts and the current is 5 amperes. What is the resistance of the electric iron? So what are the given things, children? V is equals to 240 volts. I is equals to 5 ampere. Then same, R is how much? Formula, V equals to I into R. Nothing but a R is equals to V by I. Implies R is equals to, what is V value? 240 volts. I is 5.0 or 5 you can take. Then 5 ones are, 5 fours are, then 5 eights are. So what is the R value, children? 48 ohms is the resistance of an electric iron. Get it, children? Now we will see the next problem, which is based upon resistivity. A wire is 1 meter long, having a diameter 0.2 millimeter and has a resistance 10 ohms, and calculate the resistivity of the material. Here, what are the things given, children? Length of the wire they has given, and even diameter, means the thickness of the wire they have given. In terms of a diameter they have given. Then resistance also given. Then what we want to know? The resistivity, that is rho value we have to find out. Isn't it, children? What are the given things? Length, L is equals to 1 meter. Then diameter, D is equals to 0.2 millimeter. So children, in order to convert this millimeter into meter, means we have to multiply it by 10 to the power of minus 3. So now 0.2 into 10 to the power of minus 3 meter is the what? Diameter value. The next is resistance. R is equals to 10 ohm and the resistivity rho is equals to, we want to calculate. So now we will use formula. That is R is equals to rho, then length divided by A. This implies what? We want to know resistivity. So resistivity rho is equals to R into A divided by L is the formula. Isn't it, children? Because in terms of a resistivity we have to use the formula. So when we change this, that is, if we rewrite in terms of a resistivity, that is rho is equals to R into A divided by L. So here comes A. A means here area of a cross section. But we don't know here area of a cross section. They have given only diameter. So how to convert that? We need to use one more formula. A is equals to pi r square. Isn't it, children? We know that A is equals to pi r square. Here r is nothing but, children, d by 2 whole square. That is pi d by 2 whole square is what? Area value. Now substitute all those values. Substitute all values. Isn't it, children? What we'll get? Rho. Then what is the R value? 10 ohms into, what is the A value? That is pi is nothing but, children, 22 by 7. It can also be written as a 3.14. Isn't it? 3.14 into, what is the D value? 0.2 into 10 to the power of minus 3 divided by 2 and whole square. And this is all divided by, what is the L value, children? 1 meter. Isn't it? This how comes, children? When we substitute all these values in this equation. You can want means for your reference, you can take it as a equation 1. Substitute all values in equation 1. Isn't it, children? We will get. This comes how? Pi is nothing but 22 by 7 or 3.4. Now 10 into 3.14 into 0.2 into 0.2 we can write now, because whole square into 3 into 2 6 means 10 to the power of minus 6. 2 square means 4. So at the denominator, when this 4 goes to denominator means 4 into 1 meter. Isn't it, children? Now we will divide, that is 2's then 5's, isn't it? 2 1's, here also 0.1 we will get. So now what has left here? 3.14 into 5, isn't it? Then 0.1 is nothing but 1 divided by 10 into 0.2 means, that is 2 divided by 10. Or else you can write this even it as a 10 to the power of minus 1 into 2 into 10 to the power of minus 1 into 10 to the power of minus 6. So this 10 to the power of minus 1 this and also this and this, that is 10 to the power of minus 1 into 10 to the power of minus 1 into 10 to the power of minus 6 is nothing but 10 to the power of minus 8. Isn't it, children? Now we can write that, that is what? When we multiply all these, you will get nearly 31.4 into 10 to the power of minus 8 ohm meter is what? The resistivity value. Isn't it, children? When we do cancellation and when we multiply all these, we will get at final what? 31.4 into 10 to the power of minus 8 ohm meter as a resistivity. Now we will see the question. How does the resistance of a conductor depends on length of the conductor, area of a cross section, then temperature? Isn't it, children? In order to answer this, you should know on what factors the resistance of the wire is going to depend. Isn't it, children? Once we can recall the formula, R is equals to rho into length divided by A. Isn't it? When we look at this equation, we can say that the resistance of the wire is directly proportional to resistivity and resistance of the wire is directly proportional to its length, and whereas the resistance of the wire is inversely proportional to area of a cross section. So the question, length of the conductor, how the resistance is depending, children? It is directly proportional. Isn't it, children? It is directly proportional. Means if the length of the wire increases means resistance also increases. If the length of the wire decreases, means what happens? Resistance of the wire also going to decrease, isn't it? This is the meaning of a directly proportional. Then comes what? Area of a cross section, isn't it? Resistance of the wire is inversely proportional, means if area of a cross section increases, means the resistance of the wire decreases. So it is what? Inversely proportional, isn't it, children? Then the third one is temperature. Resistance of the wire increases with increase in temperature and decreases with the decrease in the temperature, isn't it, children? So it is what? Directly proportional, isn't it? Now the second question is, what would be the effect on the resistance of the wire if we increase its length, isn't it, children? What is the resistance if the, imagine that this is a wire, isn't it, children? If its length got increased by this much, then what happens to its resistance? It is directly proportional, children. Here the resistance also increases, so we can write resistance will increases. Resistance increases, isn't it? The next is increasing its diameter, isn't it? A is nothing but a diameter square. It is inversely proportional. Suppose if we increase its diameter, means that is resistance is reducing, isn't it? Means the resistance will decreases. Got it, children? And what happens to its temperature? The resistance here also increases, isn't it, children? See, this is what effect of resistance on the wire. Suppose if for the same question, if they have asked its length got increased by 2 times, isn't it, children? For this, if L is increased by 2 times, then what is the resistance? Means you have to write R is equals to 2, because it is directly proportional. How much length you are increasing, that much amount of resistance also going to increase here. Got it? Suppose if we increase its diameter, means d square, isn't it? That is what? D square. It is at what? Inversely, no? So R is inversely proportional to diameter square. So suppose if diameter gets doubled, imagine that D has become 2 times, twice. Then the resistance will become how many times? That is 1/4 time. Means it has reduced, means it has decreased to 1/4 time. If diameter of the wire, imagine that this is a wire, its diameter has got increased by 2 times, then its resistance will reduce to or decrease to 1/4 time, isn't it, children? By the same way, you have to answer based upon the question what they have asked. It might even they might have asked, like if the diameter of the wire got increased by triple, means what would be its resistance? Means 3 times, that is 1 divided by 3 square. Then resistance will becomes there 1/9th time it will affects, means it will decreases. Got it, children?